A very good evening to Madam. My name is Nur Akila binti Ilyas and I'm from CE1 Group 40. My group consists of me and also Amir. So today we are going to present you the project entitled Methanol Production Using Steam Reforming Process. So this presentation will cover Chapter 1, Introduction, Chapter 2, Process Flow Diagram, and also Chapter 3, Chemical Engineering Thermodynamics. So now let us move on to Chapter 1, Introduction. So methanol is commonly being used in vehicle fuel blending, such as gasoline, to produce a high octane gasoline so that it has a better quality, and also marine fuel to being blended with gasoline as well in order to produce excellent quality fuel known as methyl tertiary butyl ether. And also methanol is being used as the feedstock to produce another chemical such as formaldehyde and also acetic acid. And it is being used as antifreeze as well in windshield of washer fluid. So it is being used as industrial solvent to produce resins, inks, and also dyes. And most importantly, methanol is flammable, volatile, and fatal for consumptions. And it consists of chemical properties which can lower the freezing point and increase its boiling point, and that's why it is being used as an antifreeze. So methanol also is being injected in the natural gas pipelines to lower its freezing point of liquid during oil and gas transport for safety purpose. So for plant capacity, there are two types of plant capacity for methanol production, which are small and big scales. So for small plant scales of methanol has the capacity of approximately 15,000 tons per year to 20,000 tons per year. Meanwhile, for big plant scales has the capacity of approximately around 1 million to 2 million metric tons per year. So for market analysis of methanol, so based on these two references, which are Methanolog and also Methanex, United States and also North America has the highest market price due to rising in demand but tightly supplied. So probably another reason is due to the pandemic that occurred this year. So for demand trend of the globally methanol market, it is expected or being forecast that it will be increased steadily until year 2025 despite of the pandemic issues, according to expert market research. So for global market usage, methanol is majorly or commonly being used as the chemical feedstock to produce formaldehyde, and secondly, it is majorly being applied as fuel application to produce a better quality of fuel vehicles. And for global market of methanol, based on expert market research, it stated that China is the largest market of demand of methanol, United States is the largest importer, and Saudi Arabia is the hugest exporter of methanol. So for selection of instrument for methanol production consists of compressor, cooler, mixer, heater, steam reforming reactor, methanol synthesis reactor, condenser, splitter, recycle operator, syngas recovery unit, methanol purification unit, and also reboiler. So now let us move on to chapter 2, which is process flow diagram. So For stream 1 and stream 2, which consists of methane and steam, will pass through the heater and also mixer and being fed into a steam reformer. And in this steam reformer, there are several reactions that occur. So this steam reformer is being used to convert methane and steam into synthesis gas. So the reaction that occurs are, firstly, the methane is reacting with the steam to produce carbon monoxide and also hydrogen. And second reaction is carbon monoxide react with the water to produce carbon dioxide and also hydrogen. So then the components in steam 3 is being fed into the condenser, and this condenser is used to remove the excess water, and the remaining components are being fed into the compressor and also methanol synthesis reactor. So for methanol synthesis reactor, the reactor chosen is the equilibrium reactor. So the components in the stream 6 will pass through or be fed into the syngas recovery unit, which is the distillation column, and as represented by stream 6, and in stream 7, which is mainly the components are carbon monoxide and as well as hydrogen, is being recycled back and into the splitter, and 10% of components in stream 7 will go to purge, and the remaining 90% will be recycled back as represented in stream 8 into the methanol synthesis reactor. So for stream 10, which is the methanol that being fed into methanol purification units, in order to further purify so that 95% grade of methanol can be obtained. So the water produced from the methanol purification unit will be sent into wastewater treatment plant. So that's all from me. Now I'll pass to Amir to further explain for chapter 3. Thank you so much.
Hello, my name is Muhammad Amir bin Ali with ID number of 23770. Okay, today I would like to present about our integration design project for the chemical engineering thermodynamic 2. So, in this project, I will explain about on chapter 3, which is the calculation part. Okay, in this chapter, there are three parts we need to calculate. Okay, so the first part and the second part is exactly the same way to calculate it, or we are using the same formula to calculate it. So for this part, we are given that the temperature is 50 degrees Celsius. So in order to find the P1 set and also P2 set for methanol and water, we need to use the Antoine equation. So in order to get the constant for A, B, and C, we need to find it from table. So as you can see here in this table, there are constant value of A, B, and C for methanol and also water. Okay, so after we substitute the value into the Antoine equation, so we will get the P1 set value and also the P2 set value. So after we get this value, we need to apply the Raoult's law equation. So in order why we use this Raoult law equation is we need to get the P value. So we don't know what is the value of x1 and also x2. So in this place, we estimate that the x value start from 0 until 1. So the interval of 0 from 0 to 1 is the 0.2, 0.4, 0.6, 0.8, and until the last one value is 1. So after we are using this value of x1 and x2, so we can get the value for the pressure. After we get the value of pressure, we need to modify the Raoult's law again in order to get the value of y1. So after we get the value of y1, we so y1 is plus y2 is equal to 1. So the value of y2 is 1 minus y1. So we will get the value of y2. And after after complete finding all these parameters, this is no, no, no. Okay, after complete finding this parameter, uh, we need to show it in the graph. So this is the graph for PXY graph. This is for a graph for the part 1. So if the user need to key in their desired value for this part, they must key in the value into this section, which is the value for the X1 only. So next is the part 2. So part 2 is basically the same as the part 1. And the difference is, the first thing is we need to find the Y1 and Y2. And y1 and y2 is the estimation of value, which is start from 0 until 1 with the interval of 0.2. So why we use the same way? It is because we need to find the pressure for this part. So after we get the pressure, we need to find the x1 value and also the x2 value. Here is the formula that we are used to find the value of P, x1 and also x2. And also this is the graph that related to the part 2, which is the PXY graph for the part 2. It is different between graph of part 1 and part 2 if the equilibrium line and also the due line is different for the both graphs. So if the user want to key in their desired value, so they need to key in as the value of y1. Okay, moving to the next part, which is the last part, is part 3. Okay, for this part, we are given that the temperature is the same, which is the 50 degrees Celsius, and we we are using the same P1 set pressure and also P2 set pressure from the part 1 and also part 2. So in this in this part, we need to calculate the value of Z1, Z2, pressure, P due, P bubble, the value of V, L, and also the ratio of V over L. So we need to use the first formula is Z2 equal to 1 minus Z1. And after that, we need to, after we get the value of Z1, we need to use the value of P due, which is the P due formula is 1 over Y1 over P1 set plus Y2 over P2 set. So after that, after we get the value of P due, we need to get the value of P bubble and also the ratio of K. So the ratio of K is P1 set, no, Pi set over P. So after that, we can get the value of X1, which is X1 is Y1 over the ratio of K1, Ki. So after we get the value of Z, K, and also the value of uh, Z, so we need to find the value for the V. So the value for V, as you can see here, V equal to Zi times by Ki over 1 plus V times by K1 minus 1. So after we get the value of V, we can find the value of L. And also after we get the value of L, we need to find the ratio for the both parameters. So if the user want to key in their desired value, they need to key in the value in in this sector, which is the value of for the pressure. But make sure that the value that users want to key in must be in the range for from P bubble until the P due. That's all from me. Thank you.